Hello everyone. Today we are going to discuss about the Spark logical architecture. Spark logical architecture comprised of like Spark core and high level API. So we are going to discuss this logical architecture in detail. From the beginning, we can say that we have a distributed Spark. So let's start the Spark logical architecture. So we have Spark core API, which is we can say that it is a structured and unstructured. So we will see both the APIs over here, and I'm making a small box for that this API, and these APIs are like written in Scala, Python, R language, Java, or SQL, right? And on the top of that, we have high level API like Spark SQL, or you can say and data frames. The data frame is also again a data structure for Spark where we can interact with the structured data. Another API is like for streaming. We have a streaming. We have a Spark streaming. In Spark streaming, we have a structured streaming. And another is your mlib, which is basically used for machine learning libraries. And we also have GraphX, which is for the graph processing. So these high-level APIs interact with the core API, and then they extract the functionality of this. Now, on the in the below side of the Spark core API, we have like compute engine, and the functionality of the compute engine is that it supports the memory management, and you can say it is responsible for task scheduling and even for fault recovery, right? On in the below of this compute engine, we have cluster resource manager, and when I say cluster resource manager, we can have many options like Yarn, Mesos, or we can also have a Kubernetes, okay, or we can have a Spark standalone cluster manager. On the bottom of this, we have storage, which is called a distributed storage. And this distributed storage can be like we can have an HDFS, or we can put S3, or we can put Google Cloud Storage, or we can have some other options like HBase, and other options are also there. So this logical architecture is actually a unified stack. And when I say unified stack, the benefit for the unified stack is if you do any kind of changes in the core part, if you do any kind of changes in the core part, automatically those are reflected over here. That means if you do any kind of changes in the core API, then it will be automatically inherit on above, right? So this is the benefit of the Spark unified stack. Okay, so now let's talk about one by one each and every component of the Spark logical architecture. So let's start with the Spark core. What is a Spark core? When I say Spark core, the Spark core is your heart of this Spark framework. So this is a heart of the framework, Spark framework. And this Spark core will provide the execution engine. Provide the execution engine means that it will help you in task assignments, schedulings, monitoring, and it will provide you the opportunity to execute your Spark application or Spark code into the executors. Okay, so this is actually provide the execution engine, and this Spark is core is your inbuilt memory computing. So this is your inbuilt memory computing and responsible to perform different input and output function. Many functions like task scheduling, monitoring, or distribution of task, or you can say fault management, fault recovery, even memory management. These are the different tasks of the Spark Core API. Now, these things are implemented in Scala, Python, and Java also. Now we will see what is a Spark SQL. Spark SQL. So when I say Spark SQL, it provides support for structured data. That means it will allow query the data via SQL languages, which is very common language. Okay. Now you can say that Spark SQL is integrated, means that it is seamlessly mix SQL query with Spark program. Okay, so that means you can write SQL in your Java code or even Python code or Scala code. Next is your uniform data access. So when I said uniform data access, that means I can connect to any data source in the same way. So this is very interesting. And it all, when Spark SQL, we have Hive integration. That means you can run SQL or you can run SQL queries or on your existing data warehouses. Or with Spark SQL, you can connect through JDBC or ODBC, right? So this is about the Spark SQL. And in Spark SQL, we can use data frames just like a Panda data frame. Then these data frames are actually an abstraction. It is like an abstraction for Spark SQL. This data frame is a Spark object. That means the columns are in the name, and then this is a distributed collection of data. In data frame, we can use more optimizations or like optimizers like a catalyst. It provides you the catalyst, which is your extensible optimizer. That means you can say this catalyst is an optimization framework and which improve the productivity and the performance of the queries. Now in this Spark SQL, we also have the concept of data sets, and we will see this concept of data set in detail. Okay. Next, we have a mlib. Your mlib is actually your machine learning libraries which supports various machine learning algorithms. Right. This machine learning libraries or mlib is approximately 10x 10 times faster than your Mahout, which is earlier used in the Hadoop framework. Now the interesting thing about mlib that it can be called from your Java programs or even Scala or even your Python programs. That is why this machine learning is how it is different from the Spark machine learning. That means this is a scalable. So this is called a scalable machine learning. That means we can scale our nodes based on the data provided to the program. Now this machine learning can be easily integrated with other tools or framework. Can easily interact with other tools and other framework. And the important, very interesting is easy development is there. Then we have easy deployment for machine learning for the machine learning pipelines. Easy development and easy deployment for all machine learning pipelines. Now, next we have GraphX. Now, when I say GraphX, that means this is for the graph computation engine. That means this GraphX is similar to your tools like your Neo4j, or you can say Giraffe from the Apache framework. So this is similar to Neo4j and Giraffe and similar tools like that. And basically it is used for graphical computation. So now in this GraphX, we have a concept of like directed graph. And in directed graph, we have a vertex or we have an edge. Okay, so we have these kind of concepts in the directed graph. And it supports fundamental operations like subgraph, joins, vertices, or you can say aggregate your messages. So these kind of fundamental concepts or operations it is also providing you, and it is having a great capability. Then you can also do in a scalable way. So that's all for this Spark logical architecture. Thank you very much.